Today's lesson is on measuring. In science, we want to be precise and accurate. In science, we use something called the SI units. These are units basically that all scientists across the world use in order for them to report in the same units. These are called System International Units. When we look at System International Units, we also use basically multiples of 10, where we have prefixes that we add to our base units. So before we review that, let's make sure we understand the base units. These units have a value of 1, so we will be adding prefixes which have certain values a little bit later on in our lecture. The first base unit we're going to look at is mass. Mass's base unit is a gram. We represent that by a little g. Volume. We measure it in cubic meters, but in science most of the time with the instruments we use, we have a liter. So 1 cubic meter is actually equal to 1 liter. Length. We use the base unit meter, or little m. Time. We use second. In temperature, we use something called the Kelvin, or capital K. We use a Celsius thermometer, and we take that measurement and we add 273 to give us our Kelvin unit. Let's take a look at mass first. Mass is defined as the amount of matter in an object. It is measured in grams. We will be using a triple beam balance. It's called a triple beam balance because it has 3 bars. So let's take a look at an example of how we would use this. So when we place an object on the pan, we have a little bar that moves up and down, and we have 3 sliding units. I will be demonstrating this for you in class. So when we look at the 3 values, we notice that the first value is in units of 1, the first bar, the second is in 10, and the third is in 100s. And you basically are moving this bar over, or in this bar over, until you actually get this line lined up in the middle over here on your balance. So once we place the object on here and we finagle with our little bars and we have this little even point, we can actually add these 3 lines up. So this object actually, if we look at it, we're going to start with the largest value, 100s. There's none. So we move over here and we look at, this is 90 and this is 8. So this weighs 98 grams. On our scale, we actually have further units between the 1 and the 2, which is units of tenths. So we'll have 10 little lines between each whole number. So let's just say that it ended up being between the 8 and the 9. So it would be on the 5th line, so it would be 98.5 grams. You'll be doing a lab and you will be measuring a few things, so you will have the experience of making sure you know how to use a triple beam balance. Okay, here's another example. So again, when we slide our unit over to 200, remember we always check to make sure that this is even. So 200 plus 40 plus 8, 248 grams. All right, our next unit of measure is volume. So we are going to use liquid volume in our science class, and we want to know how much liquid is in a solution. So most of the time it's small units in our class, so we're going to use small, what we call graduated cylinders, and these are going to be in increments of milliliters. So here's an example of a graduated cylinder, and I will be demonstrating this to you. So notice it does come in units of 1s and all the way up to 25. So this one only measures up to 25 milliliters. We have different sizes in the lab that you'll be working with. So before we actually show you one, let's talk about how we actually read a graduated cylinder. When we read a graduated cylinder and we pour liquid into it, that is, most of our liquids have the solvent water. So water has a special quality where it has a high surface tension, and it basically, what happens to each little water molecule is they move up along with each other. So what happens to water, it actually sticks to the walls of our container, and gives us kind of like a false reading. So what we must do is we must place our object on a surface, look at the water level, and we like a little curved smile. We want to look at the bottom of that curved smile. So that curved smile, we give it a name. We actually call it a meniscus. So this meniscus is a curve of the surface of the water in our graduated cylinder. So if you would measure an object, and you would, liquid, you would pour your liquid in, and you would see like kind of like if you looked at it at eye level, you would see kind of like a little clear area up here. So what you want to do is you want to take the bottom of that line and you want to take your measurement there. So for example, this particular liquid's volume is 73 milliliters. Alright, let's take a look at length. So when we measure length, we want to see the length of an object. Most of the time we're measuring in very small quantities. So we're going to use our metric ruler to do that. And sometimes we need to use our meter stick if we're going to measure something very large. So when we look at this, our metric ruler, we see very large numbers and then we see very small numbers. So a lot of students get confused between these two. The centimeter means 100, tens, 100s actually. So what we see is our large numbers are centimeters and our smaller units right here are milliliters. So there are 10 milliliters in 1 centimeter. So this would actually be 1 millimeter and this would be 10 millimeters or 1 centimeter. So we'll get practice using this again when we do our measurement lab. So again, make sure we understand that the larger number is our centimeter, the shorter number is our millimeter line, and we always line up the ruler to the beginning of our object where we start with 0. And so for example, let's look at this this metal rod. And if we take a look at this metal rod, and I want you to take a second and see if you can actually determine the length of this metal rod in centimeters. Okay, if you got 4.8 centimeters, you were correct. So let's take a look at how we did that. So this is 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters. This is between the 4 and the 5. We have 10 lines. Okay, so if we count, we go 1, 2, 3, 4, 5, 6, 7, 8. So this measurement would be 4.8 centimeters. Now if I ask you how many millimeters that was, you can actually look. Each one of these lines is a millimeter. Do you have to sit there and count every little line? No, because you know that there are 10 millimeters in 1 centimeter. So now you just count in multiples of 10. So 10, 20, 30, 40, and now we do single units. So 40, 1, 2, 3, 4, 5, 6, 7, 8. So this metal rod would be 48 millimeters. Okay, when we look at our metric system, all scientists use the metric system. It is based on what we call the multiples of 10. And each multiple of 10 has its own unique prefix. You're going to just have to memorize these. Okay, so when we look at our base unit, we just defined it a little while ago. Grams is our base unit of mass. Liter, our base unit of volume. Meter, our base unit of length. So remember I said that these base units have a value of 1. So what if we have something smaller or bigger than 1? Well, we use basically multiples of 10. So if something is larger than 1, we're going to use the 10 is a deca. Oops. Hecto is 100. Kilo is 1,000. So these two, hecto and deca, we do not use in biology or chemistry very, very much. We use mostly kilos, K, which is a prefix K, and its value is 1,000. So let's look at units smaller than 1. So we do have things that are small that we are going to measure. So when we look at these, if something is 1/10, okay, its prefix is deci, D. Centi, 1/100th, is basically C. Milli, 1/1000, is M. So let's take a look at how we would use these together. So let's say we wanted to represent a millimeter. So you would write milli, M, and then you would add meter, M. So that would be a millimeter. Sometimes we have to convert from one unit to the other. So the basic rules from converting from large to small is to multiply, or to convert from smaller to large, you divide. So let's take a look at this. So basically, when we look at our base units, our gram, or gram, or liter, or meter, we start here, and if we want to convert, then we just move from one unit to the next. So let's practice with 1, okay? So every step up on your chart, you need to divide by 10, or you can move your decimal place one place to the left. So if you go up, you move your decimal place to the left. If you move down the ladder, you're going to move your decimal place to the right. This is something you just have to memorize, okay? So if you move if you're going up on your scale, you need to move your decimal to the left. If you move down on your scale, you need to move your decimal place to the right. How many ever steps you move up or down. So let's take an example. So we want to convert 10 meters to millimeters. So notice you have right here 1 letter. So that means you're dealing with a base unit. So if you look over here, millimeters, milli is the little m in front of the meter means you're dealing with millis. So let's see how we can convert 10 meters to millimeters. Okay, so let's look at our chart. So we're going meters, base unit, to milli. We're going here. So if you notice, how many steps do you take down your scale? You go 1, 2, 3. So we are moving down our scale. So when we move down our scale, we need to move our decimal place to the right. So let's look at our example. Okay, so here we are. Here's our decimal. It is, of course, remember whole numbers. It is assumed our decimal place is behind that whole number. So we just said we needed to move our decimal place 3 places to the right. So here's our decimal, and we move our decimal 1 place, 2 places, and 3 places. And again, we do not write it there, we just leave it and add our zeros. So 10 meters is equal to 10,000 millimeters. Another good way for you to check this is, we're going to give you kind of a clue in just a few minutes. But it's easy. If you know that a meter is equal to 1, and you know milli is smaller. So if you're going from a very larger unit to a smaller unit, your number needs to be larger than what you began with. It's the easiest way for you to check. Let's do one more example. So we want to convert 1 centimeter to a meter. So we're starting on our scale. We have cm here, so we know it's prefix centi, and we're finishing with a base unit because it's only 1 letter, meter. So let's go back to our scale. So we're going from centi to meter. So we're going from centi to meter. So we're going 1, started centi, 1, 2. We move 2 places up. So remember, when you move up on your scale, you need to move your decimal place to the right, that many spaces. So let's go back to our example. So here's our decimal. We need to move to the left. So if we move our decimal place 1 space, 2 spaces, in that space that you moved, you need to add a 0. So you add a 0 in front of your decimal and you get 0.01 meters. Again, another way to check. You're going from a smaller unit to a larger unit. So therefore, your number that you finish with should be smaller, okay, than what you started with, and it is. Okay, so now what we're going to do is your classwork is here. We're going to let you do a few at a time, and we'll check you out and see how well you do.